Hey everyone, how's it going? Today I want to talk about military innovation, pushing boundaries, and breaking more conventional norms. I feel like very often you'll see some kind of news story or a video about this new piece of military technology that, at least according to the story, is really going to change the battlefield. Something that's this incredible piece of technology and just a marvel of modern engineering. And then, past that video or article or whatever you saw, you then never hear about whatever it was ever again. Or at the very least, you don't hear about it for a very long time, and when it finally reappears, it looks a lot different. A great example of this that always pops into my head when I think of new advanced military tech is the DARPA Reconfigurable Wheel Track, or RWT. That was momentarily kinda popular back in mid-2018. In an article on Popular Mechanics, the first sentence talks about how DARPA is revolutionizing how ground vehicles move across rough terrain, and admittedly it looks really cool and futuristic, combining more normal tires with tank treads for the best of both worlds. But in the almost 7 years since mid-2018, I can't say I've heard anything more out of this project, and it doesn't appear as though these RWT wheels are going to be appearing on military vehicles anytime soon. And when you really start to think about the design of these wheels, they start to lose their luster a little bit, and go from something that's revolutionary to something that's neat in concept, and not really in practice. For one, the reason tires have air in them, instead of just being solid rubber or something like that, is to reduce shock, and these tires clearly don't have any air in them, nor do they appear to have any kind of system to provide that shock absorption. As a result, on rough terrain, these tires would likely be a really rough ride. But I think the bigger issue would be the durability and reliability. On one hand, there appear to be a lot of moving parts, very small moving parts, that probably end up being vulnerable to dirt, debris, and damage. Then, on the other hand, if the vehicle were under enemy fire, which it is a military vehicle, I have doubts that these wheels would hold up all that well, again because of these smaller moving parts and whatnot. Presumably, for these things to be viable for military use, they would either need to be simplified and strengthened, or they would need additional armor to protect their more vulnerable parts. And doing either of these things would end up hampering some aspect of what it was designed to do. While it is really cool, again, it doesn't seem to be terribly viable for the military at this point, and it's really just a cool idea. Maybe at some point in the future it will end up being viable though. But that's also something that could be said about most military technology in history. It starts out not being viable, but after other technological advancements, further refinement of the design, and or just new ways of thinking about things, the once non-viable tech then becomes a lot more viable. Take tanks as a great example. When they first appeared in the First World War, while they were used on the battlefield in pretty decent numbers, due to limited understanding of the concept and severe technological limitations, early tanks were very niche and often just more annoying than what they were worth, more likely to just break down than pierce enemy lines. But a little more than 20 years later, tanks were a centerpiece of Germany's ground game in the Second World War. Tread designs were refined, engines were stronger, the concept of what a tank should be evolved, and tanks then became a vital piece of any military's arsenal. So, with all of that in mind, for our subject for today, we have something that certainly wasn't as game-changing, but was nonetheless innovative in its own right and boundary-pushing, and it did something that was very much not common and not considered very practical at the time, but became more practical later on. This is an early attempt by the US Navy and by Grumman to bring a twin-engine fighter to aircraft carriers. This is the Grumman XF5F Skyrocket. The story of the Skyrocket begins back in the mid-1930s, with the US Navy looking to potentially bring a twin-engine single-seat fighter onto its full-time roster, with what was the current state of military aircraft and engine technology. To improve the combat performance of naval aircraft, the US Navy was under the impression that fighters would have to go from single-engine to twin-engine. And in 1937, the US Navy officially requested designs for a single-seat twin-engine fighter. For some reason, the Navy believed that even though engines would increase in power, their top speeds would not improve, and to get a carrier-based fighter above 300 miles an hour, a second engine was needed. Now, due to the inherently limited space on aircraft carriers, this belief was a really problematic one for the Navy. The addition of a second engine on the frame would have a sort of trickle-down effect of making the plane bigger overall, the weight higher, the wingspan greater, etc. This increase in size then decreases the number of planes that could be held on the carrier, and limiting the number of planes on that carrier was frowned upon. Now, planes could, and often did, have ways of saving space, like through folding wings and whatnot, but with twin-engine aircraft having their engines in the wings, this inherently reduced the amount of space that could be saved. This is all to say that the Navy had a real conundrum on their hands. This is likely why, when the Navy asked for twin-engine aircraft designs coming from all manner of respected companies like Grumman, Vought, Brewster, Curtiss, and Lockheed, all of their designs were rejected. None of them apparently offered enough of a performance boost that warranted the greater space that they would take up on the carrier. Of course, this initial failure didn't prevent the Navy from searching for a new fighter design or anything like that. I mean, that would be kind of ridiculous, wouldn't it? And in early 1938, the Navy once again solicited new designs for a new fighter. This time, though, the fighter wasn't explicitly to be a twin-engine one. It certainly could be, but it would have to be a pretty spectacular twin-engine fighter to overcome the detriments of that extra engine. The exact design that the Navy was looking for wasn't terribly specific. Mentioned in the specs was that the design could use the Allison V1710 inline liquid-cooled engine. It could also be a twin-engine plane that weighed less than 9,000 pounds, but overall it would need a top speed that was greater than 350 miles an hour. It would need a stall speed that was less than 70 miles an hour. It needed a range of 1,000 miles, and it needed the ability to take off in 200 feet in a 25-knot headwind. Once again, receiving numerous submissions from several companies, the Navy ended up settling on 3 of them by late June 1938, and all of them were pretty innovative in some fashion. From Vought would be their XF4U, from Bell would be their XFL, and from Grumman would be the XF5F. Here's what made each of these designs unique. The XF4U, the famous Corsair, was to use a prototype Pratt & Whitney R2800 with 1,800 horsepower, a very strong engine for the time, and when it was installed, it would be one of the most powerful engines on a carrier-based aircraft in the world. The XFL, which I'm actually working on a short video for at the moment, was a derivative of the P-39 and shared in some of its more unique elements. Then for the XF5F, as you can see, its design was incredibly unique, both for a carrier aircraft and just a fighter aircraft in general. For one, Grumman stuck with the twin engines, electing to go with 2 smaller, less powerful ones, instead of just one larger, more powerful one. Instead of going with something like the R1830 or following in Vaught's footsteps with the R2800, Grumman intended to go with the older, smaller, much weaker R1535 Twin Wasp Jr., with just 750 or so horsepower apiece. But it had the benefit of being pretty light and having a smaller diameter, weighing around 1,000 pounds, 250 less than the R1830, and about 1,300 less than the R2800. The combination of two of these engines, so around 1,500 horsepower at 2,000 pounds, gave it more power than the R1830, slightly less power than the R2800, but less weight than the R2800. So it was kind of an in-between. But honestly, the choice of an older, more outdated engine was relatively normal when compared to the rest of the very bizarre design, with the wing, the tail, the fuselage, just everything about it, really. Personally, looking at the design kind of like a Rorschach test, I think it kind of looks like a fish holding a plank of wood in its mouth. And it's kind of adorable. Grumman decided to go with a rather bizarre-looking wing-first quasi-noseless design. This wasn't done just for the fun of it, though, and it had a very specific purpose of eliminating one of the issues of twin-engine planes, in that the wingspan is often too great for carriers. Designer Dick Hutton came to the very obvious realization that if the engines could be moved more towards the center line, more towards the fuselage, this would help reduce the wingspan. The question then was how? On a more standard design, the engines could only be moved to the center so much, before the whole fuselage got in the way. So if the fuselage was in the way, Hutton decided that the best way to fix this was to take the wing and push it somewhere else, all the way up to the nose and slightly beyond. About 2/3 of the wing stayed in the plane's nose, and the rest extended past it. This gave its two engines and two propellers the ability to move closer to the center line, and the gap between the two propellers was quite small. Despite this meaning, then, that the wingspan could be shortened, the XF5F design was actually still pretty wide, measuring 8.76 meters long, 12.8 meters wide, and 3.45 meters tall. This wingspan was about 1/3 of a meter more than the XF4U, and 1.3 meters more than Grumman's own F4F Wildcat. Of course, this is not factoring in the folding of the wings, which on the Skyrocket folded just after the engine nacelles. Now, while this difference in the wingspans doesn't sound like all that much, every inch, every foot, every meter or centimeter counts when you're dealing with very limited space, and this greater wingspan of the XF5F, even if it was only slightly more, would still be a mark against it. Then, moving back from the wing into the nose and cockpit, the XF5F would contain its armament solely in the nose, in an effort to make aiming much easier for the pilot. Initially, it was planned to have a combination of two 50 cal and two 30 cal machine guns. It was also proposed, though, that this could be swapped out for 20 mil cannons, 23 mil cannons, or even 37 mil cannons. Right behind the nose and the armament in it sat the cockpit with a more bubble-style canopy that gave the pilot great vision all around. And with its very stubby nose, this also ideally gave the pilot excellent vision directly in front and below him, which would be helpful for takeoff and landing. Moving back to the tail, the XF5F would feature a twin-fin design, which was not terribly common for smaller fighter aircraft. This overall design of the XF5F was actually sort of the beta version of the original design. The alpha version, if you will, had a lot more of a basic design. As you can see from this very early small wind tunnel tester model of it, the XF5F went through quite a few changes to reach its more bizarre final form. The earliest iteration of it kinda just looked like a weird conversion of an F4F Wildcat that was configured to hold twin engines. The initial concept was a lot more normal looking, and what it ended up becoming was a result of this little model being wind tunnel tested. The original nose design would extend slightly past the wing, but in that initial testing, it showed the need for increased airflow over the wing, specifically between the engines, and in general it would need increased stability, which overall led to its nose job and tail redesign. Additionally, very early on, the smaller and weaker R1535 engines ended up being swapped out for R1820 engines. This was largely due to engine availability, as the R1535 was an older, out-of-style engine, and the R1820 was newer and more powerful and more common, which in turn would make it easier to use on a production aircraft. This was an order that came directly from the Navy, but weirdly the Navy didn't seem to be completely thrilled by their decision, in part because the larger 1820 engines reduced pilot vision a little bit. But still, it was a relatively minor sacrifice in the grand scheme of things to make the design more practical and viable. So with these design modifications, the XF5F had a mock-up made, inspected, and improved in 1939, and by early 1940, the first Skyrocket prototype was complete, and on April 1st, 1940, it would take to the air for the first time, for a brief and problematic first flight. It was a bit difficult to get a true read on the plane in its first flight, as its engines ran very hot the entire time, and that made the main focus of the first flight the engine temperature. This issue then necessitated a redesign of the oil cooler air intakes, and while they were doing this, they would also redesign the doors for the retractable landing gear, as it was also discovered in these early flights that the landing gear doors often failed to close properly, resulting in increased drag and overall reduced performance. So with these early modifications out of the way, the Skyrocket returned to the air once more for more extensive testing, and test pilot Selden Converse gave the Skyrocket a pretty solid report. Overall, it flew quite well. He liked the fact that its twin engines used counter-rotating propellers. The vision from the cockpit was fantastic, and it was relatively easy to control and perform various maneuvers. He did also note that some of the control surfaces were a little heavy, but overall it showed decent promise. With this promising performance, on February 22, 1941, the Skyrocket was transferred over to the Navy at the Naval Air Station in Anacostia for further flight testing and official evaluation. This was pretty short-lived though, as the XF5F was handed back to Grumman for modification and further redesign less than 2 months later. In addition to an alteration of the entire hydraulic system, the Skyrocket's unique and adorable little stub nose had to be modified to a slightly more standard and less interesting longer nose that extended past the nose-mounted wing. In conjunction with that, the engine nacelles would be extended, so that instead of ending abruptly around mid-wing, they extended past the trailing edge, and the cockpit canopy was shortened. All of this was done for both aerodynamic and armament reasons. While initially the idea of putting cannons in the Skyrocket's nose was more of a what-if thing to shoot for down the line, the Navy was considering it much more seriously right now, and to fit that stronger armament, the nose would need to be bigger in some regard to hold the larger cannons, Additionally, in some smaller scale testing, it was found that if a longer, more pointy nose was installed, along with having the engine nacelles extended and the canopy shortened, the top speed of the Skyrocket could be increased by as much as 18 miles an hour. This potential top speed boost was incredibly vital, as its competition was starting to show some incredible speeds for single-engine fighters. In late 1940, the XF4U managed to hit 400 miles an hour in level flight, and over 550 in a dive, whereas the Skyrocket was only managing 505 in a dive. Basically being 50 miles an hour slower, the Skyrocket needed a solid boost in speed to catch up with the now starting to pull away Corsair. Even as the Corsair was proving itself to be overall the more promising plane, the Skyrocket did have one major benefit going for it that was better than just about every other Allied fighter at the time, and that was an incredible climb rate. While the Corsair ended up having a fantastic climb rate down the line, in mid-1941, the XF5F and Corsair, along with the XFL, the P-39, the P-40, the F4F Wildcat, the Brewster Buffalo, the Spitfire, and the Hurricane, they were all participants in a little competition to compare each plane to one another and see which one performed the best. Aside from its counter-rotating propellers that eliminated the effects of engine torque and the excellent vision from the cockpit, the Skyrocket would really earn that name due to its incredible climb rate, which made the other competitors in the competition look so sluggish that the pilot of the Skyrocket thought everybody else was having engine problems. Its 4,000 feet per minute climb rate was well above the other competitors. The Corsair eventually managed to top this climb rate later in life, but at the time, the Skyrocket reigned supreme in this realm. At the very least, this incredible performance in this one specific area gave the Skyrocket a sort of floor. At the very least, it would likely be able to serve quite well as an interceptor, to take quickly to the skies and take out enemy aircraft. But to serve as a more general-purpose naval fighter, a lot more would have to be improved upon. The longer nose, while increasing speed, decreased lift and increased the landing speed. The stability and the controls were still a little bit problematic, and the top speed was still pretty low, maxing out at around 358 miles an hour in its ultimate form. Following further Naval Air Station testing in early 1942, that would see multiple landing gear failures that damaged the prototype, Grumman just threw their hands up and seemed to have had enough. And on March 31st, 1942, Grumman officially requested to the Navy that the project be cancelled. At least partially, this request was because so much needed to be improved upon for it to be a viable fighter, and Grumman just didn't view it as being worth it. But it was also much more so because Grumman was in the initial stages of a new twin-engine naval-based fighter, one that was much larger, much faster, and much more powerful, in what ended up being the F7F Tigercat. It took several months for the Navy to accept Grumman's request, though, and in the meantime, the Skyrocket saw token use and quote-unquote development until mid to late 1942, where the cancellation request was finally granted. The lone Skyrocket prototype would then see very limited use for the next 2 years, not as a viable prototype or anything like that, but just as a sort of general use utility plane at the Anacostia Naval Air Station, until on December 11, 1944, it crashed and was deemed beyond repair, bringing a quiet end to one of the most bizarre-looking fighter designs of World War II. But back on the point of the Skyrocket having a decent floor, Grumman did attempt to promote the design to the Army in their search for a high-altitude interceptor as the Grumman XP50. The overall design was a little bit different than the Skyrocket, sporting tricycle landing gear, a slightly longer fuselage, and stronger engines. It would also keep the longer nose of the later Skyrocket model. With these improvements though, the XP50 had a much higher top speed of 424 miles an hour. However, these improvements were all for naught, as the first and only XP50 was lost pretty quickly on May 14, 1941, after the explosion of a supercharger mid-flight forced the pilot to bail out, leaving the plane to hurtle back down to Earth, splashing down into Smithtown Bay off the north coast of Long Island, New York. Circling all the way back to the very beginning of the video and the concept of innovation and breaking boundaries, not only was the general design of the Skyrocket a major departure from more conventional norms, but just the fact that it was a twin-engine carrier-based fighter was itself a major departure from norms. While we wouldn't end up seeing designs like the Skyrocket in the future, twin-engine fighters in general did become more practical as time went on, or at least for the relatively brief period before jet fighters ended up reigning supreme. Carriers in the Skyrocket's time were generally much smaller, which again meant that single-engine fighters were more optimal. But towards the end of World War II, with the introduction of newer, larger carriers, twin-engine fighters and just bigger fighters in general became more viable for use on carriers. If not for the proliferation of jet engine technology, it's very likely that larger twin-engine prop planes like the F7F Tigercat would have seen significant use on carriers, setting a new standard of high-power prop planes that the Skyrocket could have been an early pioneer for. But instead, because of jet power, the Skyrocket now is more relegated to being a very strange experiment. Alright, and with that, we're going to go ahead and end for today. So thank you all for watching. Remember to like, comment, and subscribe. Now, I'm sure everybody watching this has heard of the whole plane and helicopter collision in DC. From what I've read on it very briefly, I mean, there's still information coming out about it, it looks like there was some kind of miscommunication with the air traffic controller, and the helicopter didn't see that specific plane. But you watch it, and it's like, how did they not see each other? They're two big aircraft in the sky. I mean, I do get how they don't see each other, you know, sight lines and all that, but just the way it looks is so bizarre to watch. But anyway, I hope you enjoyed the video, and I hope you learned something. So, see ya.